Hi stat students, today we're going to be talking about section 10.3, hypothesis testing for population proportion. So population proportion, meaning we're talking only about categorical data or pi in this video. Before we get going, we're going to go over some important vocab and some testing norms and expectations. Really important definition for us is a p-value. A p-value is the measure of inconsistency between the hypothesized value for a population characteristic and the observed sample. In other words, this is the probability assuming that the null is true, of obtaining a test statistic value at least as consistent with the null as what is actually resulted. Okay, we call a test an upper tail test if the alternate hypothesis is that pi is greater than the hypothesized value or the null. So what we've got going on here is we have a curve centered at the null hypothesis. And in the upper tail, we have designated an area of possible error. That's where alpha exists. We're looking at the probability given a sample of support for our null. So we'll get one sample and we'll get a z-score somewhere. We don't know if it will be here. We don't know if it will be here. But we'll get a z-score, and we're looking at the probability of getting another sample from our population that is similar to this one, so that we can draw the conclusion about which hypothesis is true or not. In order to determine that, we look at the probability of that z-score being greater than, the signs should match, whatever we calculate it to be. And if that's less than or equal to alpha, then we reject the null. Because basically what that means is that we have an unlikely sample. This would be an example of a rejection. We have an unlikely sample and it's falling into our area of error. So we would falsely choose the null. It's falling in the area of type 1 error. Okay. A lower tail test is one when the value is less than, the alternate is less than the hypothesized value. So alpha's in the lower tail. And we look at the probability of the z-score being less than whatever it is that we calculate. And if that probability is less than or equal to alpha, we reject the null. And last but not least, a two-tail test is when the alternate hypothesis is that pi is not equal to the hypothesized value. And since we do not know if that value is less or greater, we split our area of error in half. So now we look at the probability of, and it depends. If the z-score we calculate is negative, we look less. If that z-score is positive, we look greater. And then we multiply that probability by 2. If that probability is less than or equal to alpha, we reject the null. So we just went through some basic testing norms or procedures, and now we're going to talk about running a specific test for categorical data, which is called a one proportion z test. I'm going to front load all the steps of the test for you, and then we'll go through 2 examples together. It's very important that you do not skip any steps in the test. I know 9 steps can seem tedious, but they include all of the information that you need to have a nice, also eloquent and formal statistical test. So let's talk about step one. Step one is always defining your parameter, and that happens to be pi in this case, in words. Step 2 and 3 don't need to occur in any specific order, but you're defining your null hypothesis and your alternate. Remember, your alternate can be less than the hypothesized value, greater than the hypothesized value, or not equal to the hypothesized value based off of the context of the problem. Step 4 is to check conditions. These are the same conditions that we've checked prior with confidence intervals. Part A is the sample random. Part B, n times pi needs to be greater than or equal to 10. C, n times 1 minus pi needs to be greater than or equal to 10. And D, since this is for large populations, n needs to be less than 10% of that population. That's an assumption we make. For step 5, we set our alpha value, and there's a couple ways that you can do this. It's usually given to you. If it's not given to you, then you're going to be asked to look at the context of the problem and weigh the consequences of a type 1 or 2 error and choose appropriately. Or, when in doubt, there's no serious consequences, choose alpha equals 0.05. Step 6, we always need to write the formula and state the name of the test. For us, this is going to be, as said before, a one proportion z-test, and the formula is that of a z-score for categorical data, p minus pi over the square root of pi times 1 minus pi over n. In step 7, you're going to use data from the sample and pi to find that z-score. And in step 8, you're going to find the p-value through your probability statement and compare it to alpha. Now, the sign in your probability statement in step 8 should match that in step 3. So for instance, if you're saying that pi is less than the hypothesized value, you're going to be looking at the probability of the z-score being less than whatever value you found in step 7 will go here. If you are saying pi is greater than the hypothesized value, your probability statement will say the probability of z being greater than whatever value you find in step 7 goes here. And for not equal to, we have a couple different instances. If that z-score is negative, we're looking less. If that z-score is positive, you're looking greater. But since you're only looking at one end of the tail, you need to multiply by 2. For all of these, if the p-value is less than or equal to alpha, we reject the null. And if it's greater than alpha, we fail to reject the null and keep our initial claim. Last but not least, step 9 is an in-context conclusion. Now let's go through 2 examples. Example 1. The vast majority of couples kiss right. 124 couples and 80 of them, 124 couples were observed, 80 of them turned their head to the right to kiss. Is this enough evidence to show the majority of couples turn their head to the right to kiss? Okay, let's start off. Step 1. Define pi. This is and will always be the true proportion of And we're looking at couples who kiss right. Okay, step 2 and 3. Step 2 is our null. Step 3 is our alternate. From the problem, there's always 3 pieces of information you should be able to pull out. What P is, that's our sample proportion. N is the sample size, and pi. Sometimes it's easier to write the alternate before it is to write the null. For instance, in this example, right here it says, is there enough evidence to show the majority of couples? Well, I know that the majority is greater than 50%. So it's easier to write the alternate first, and we know that this has to be the same number, so the null is equal to 0.50. All right, I know that my sample is of 124 couples, and sample proportion is success over total, 80 out of 124. That's 0.645. Okay, step 4, check conditions. Is it random? Not stated, so we'll assume. B, N, 124 times 0.5, that's greater than or equal to 10. And C, 124 times 1 minus 0.5 is still greater than or equal to 10. Step D, 124 is less than 10% of the population. 5, there seem to be no serious consequences for a type 1 or 2 error in this problem, so when in doubt, alpha equals 0.05. Step 6, we're going to regurgitate our formula. This is a 1 prop z test. This is important because we will have more tests to choose from very soon. And here's my formula. Z is p minus pi over the square root pi 1 minus pi over n. Step 7, we're actually going to calculate the z-score. Z equals p, which is 0.645, minus pi, 0.5, over 0.5 times 0.5 over 124. You can crunch this out, and it turns out to be 3.233. Step 8, we're going to write our probability statement, and remember, the sign in step 8 needs to match the sign in step 3. So I'm looking at the probability of a z-score greater than 3.233. We can find this using normal CDF. Lower bound 3.233, upper bound something large. Mean of a z-score, or standard curve, is 0. Standard deviation is 1. And this turns out to be 0.000613. I compare that to my alpha level of 0.05, and it's less than. So I'm going to reject my null in favor for the alternate. So in step 9, here's how we write these conclusions. With a p-value of 0.0613%, the data suggests the true proportion of couples who kiss right is indeed over 50%, or in this case you could answer the question that yes, the majority of couples do kiss right. Okay. Example 2, the CEO of a large electric utility company claims 80% of his 1 million customers are very satisfied with the service they receive. To test this claim, the local newspaper surveyed 100 customers using simple random sampling. Among the sampled customers, 73% say they are very satisfied. Based on these findings, can we reject the CEO's hypothesis that 80% of the customers are very satisfied? Okay. Remember, there's 3 pieces of information we'll pull from this problem. P, sample proportion, N, sample size, and pi, of course. All right, let's get started. Step 1, let's define pi. Pi is the true proportion of, and in this case, it's customers that are very satisfied. Step 2 and 3. Set up the null and the alternate. In this case, the null is given to you very plainly. It's told right here that he claims 80% of the 1 million, so he's claiming pi is 80%. So pi is equal to 0.8. N is 100 customers, and 73% is 0.73, that's P. So you have two ways that you can interpret this. You could decide to test it as not equal to, because we're claiming it's not equal to 80%, that he's just lying. Or you can claim that it's less than 80% because, we do have a sample of 73, which kind of indicates that we think he's lying, and it's not lying for the greater, but lying for less. So we'll say it's less than 0.8. Step 4, check conditions. Is the sample random? And the answer is yes, it's stated as using random sampling techniques. B, n is 100 times pi is 0.8, that is greater than or equal to 10. C, n is 100 times 1 minus 0.8, that's 0.2, still greater than or equal to 10. And D, 100 is less than 10% of that population, and we can actually verify that since we know the population is 1 million. Step 5, alpha is equal to 0.05, that's given. And step 6, we're going to just rewrite our formula. This is a 1 prop z test with the formula z equals p minus pi over the square root of pi 1 minus pi over n. Step 7, calculate the z-score. P is 0.73 minus pi is 0.8 over the square root of 0.8 times 0.2 divided by 100. And this result is negative 1.75. Step 8, remember the signs need to match step 8 and 3. So I'm looking at the probability of a z-score being less than negative 1.75. I'm going to use normal CDF. Less than, I've got a negative lower bound, something large. Negative 1.75, 0 and 1. And this probability ends up being 0.04. I compare that to my alpha level of 0.05 and it's still less, so I'm still rejecting the null. In favor for the alternate. So in step 9, with a p-value of 4%, the data suggests the true proportion of customers who are very satisfied is between, no, sorry, not between. I'm thinking like I'm writing confidence interval here. Is less than 80%. Yes, we can reject his claim. Okay, so when doing your practice and your homework, make sure you follow all 9 steps, and see you later. Bye.